of a question, this question looks quite interesting. The fortunate thing is that it's a 2-mark question and a 1-mark question. So we don't necessarily have to panic. It says the roots of a quadratic equation are given by x is equal to this. So remember, roots just refer to the solutions of an equation. You see, that's what roots are. That's what roots are. Roots refer to the solutions of an equation. Now, the idea is, we can already see here before reading the rest of the question, depending on the value of k that we put into our expression, the value of k that we put into our expression is what's going to determine the answer we get for x. Because as you can see here, if your value of k keeps going up, eventually, I mean, we can have whatever answers we want. But then if your k value goes down, let's say until it's like a negative value, we might eventually not have solutions. If let's say k is like a ridiculously small number, like for example, if k is like -3, then this automatically becomes 8 times a -3, which is like -24. And then 20 minus 24 will give you like a -4, and then you can't put a negative under square root, so that won't work, you see. So I'm just going to give the idea that k can go as low as a specific value, but then k can go as high as infinity. You see, it will always give you a valid answer. But anyways, that's not too, we don't have to think about that now. Fortunately, here they're actually telling us what k can be. So they say here the roots of the quadratic equation of a quadratic equation are given by this, and here this is actually limiting what k can be. They said k can either be any of these numbers. So remember, this is not including numbers between -3 and -2. This is specifically only pinpointing out these specific integers. You see, if they wanted to refer to every single number between, like, let's say -3 and 3, they would have written it as k is an element of, you know, -3 and then 1 comma and then a 3 like that, you see. But the moment you see that no, I mean brackets, sorry, they would have said k is an element of maybe like square bracket here, square bracket there, and then a semicolon in the middle. If they wanted to include every single number between -3 and 3, this is what they would have done. But then because here they have like individually put like -3, -2, and all that, it's just specifically these numbers that we're going to consider for k. So that being said, the first mark here, the first question, right, they said write down 2 values of k for which the roots will be rational. So the fortunate thing is, whenever you think of roots being rational, or rather when you're thinking of the nature of roots, you always want to consider the portion that's like under the square root, because the portion that's under the square root is the part that somewhat has some form of power when it comes to the answers that you get. Because the rest is a fixed number, this is a fixed number. But then down here, the number can change based on what k is. So what you would want to do is, in this kind of a situation, right? Remember, they're asking us for which values of k will the roots be rational. So this is where your nature of roots, what you may call theory, comes into play. Anytime you deal with a situation where they're asking you where your roots are rational, you want to think of a situation that will result in this thing here being a perfect square. You basically want to think to yourself, what can we do to this expression so that it comes out as a square number? Fortunately, as you can see, we have options for k that we can throw in here, because all we want to think of now is what value of k can we put in here that will result in this thing here being a square number. So the first thing you can do for yourself is you can actually write out a few square numbers. We know we have like 1, 4, 9, 16, 25. What's the next square number? 6 times 6 is like 36. 7 times 7 is like 49. 8 times 8 is like, I think, 64. 9 times 9 is like 81. 10 times 10 is like 100. So these are a few square numbers that we have just written out. Now we want to think to ourselves, what number of k can we think of that will give us one of these, you see? And clearly it can also be a negative number. So let's try -2. If k is a -2, you will have here -2 times 8, which is like -16. And then 20 minus 16 will give us a 4. Let me repeat while writing it out, right? Let's say here, let k equal to -2. If k was a -2, we would have here 20 plus 8 multiplied by -2. This would result in us having 20 minus 16, which is going to give us a 4. And 4 is a square number. So for us to have a square number here, k can be a -2. So that's one of our answers for this particular question that is talking about where our roots are going to be rational. Because if they're talking about having rational roots, you look at the portion under your square root and you want to find out what can be done for that portion to come out as a square number. So the first thing is we can take k as a -2. Let's see what happens if we take k as -1. If you take k as -1, you will practically have 8 minus, you'll practically have 20 minus 8, which will give us like 12. 12 is not a square number. If you try k as 0, it's not going to work out, because if you try k as 0, you're going to have 20 plus 0, which is, just not going to work. But then I'm getting this call, and it is definitely important. Let me just pause this. I'll be back now and see what we can do. So for the first one, what you may call, I think that was fine. Wait, again, hi, Bowman. Hold on. Oh, okay, no, she's added. Yeah, so if you saw what we did for the first one, that was not too crazy. Now we somewhat have to do the same for our second value, because I want 2 values of k. So the first one we said k is going to be -2. The second one we tried 0, we tried -1, it wasn't working. If you try 1, it's not going to work. If you try 2, it's definitely going to work, because 2 times 8 is 16, and then 16 plus 20 gives you 36. So here, let's just test it out. Let k equal to 2. If k is a 2, as you can see, we're going to have 8 here times 2, which is 16, 20 plus 16, which is 36. So yeah, that's fine, you see. So that's how you would work out something like 1.3.1. We want to work out a value of k where this thing here is going to be a square number. For 1.3.2, you're going to do something similar, right? But it says here, write down one value of k for which the roots will be non-real. Remember, for us to have non-real roots, it's all a matter of having a value under our square root that's a negative number. Because if you have a negative number under your square root, you will automatically, what you may call, if you have a negative number under your square root, you will automatically have a value that is non-real, because you cannot have a negative under the square root. So for us to have a negative under the square root here, we can see that our value of k, if we choose, let's say something like -2, it's not going to work, because -2 times 8 gives a -16, and then 20 minus 16, it's a +4. So that's not going to result in a non-real root. But then if you choose -3, you see, if k is a -3, then automatically you're going to have here 8 times -3, which is -24. And then 20 minus 24 is going to give you a negative number, which would result in you having non-real roots. So for 1.3.2, one thing we can say here is let k equal to -3, test it out just for the vibes. Then here 20 minus 24, -4, you see. So here, therefore, k is equal to -3. -3 works. Here, +2 worked for the previous question, and then -2 also worked there. So that's how we would do these two questions here. Now remember, based on what we have just done, it goes back to you knowing your theory of what you may call, of your nature of roots. If your nature of roots questions are not, up to standard, if your nature of roots knowledge is not up to standard, then these kinds of questions, they are not going to be friendly. So let me just stop this here and actually see what